So part 2 of types of chemical reactions. We talk about the third example or types of chemical reactions, which is single displacement reaction. So the rule is element replaces similar element, and here if X is a metal which will carry positive charge, replaces positive charge in the compound. Now if you have Y plus AB, what are the product? Here for example, if Y is non-metal carry negative charge, and here A is positive and B is negative charge. So the rule is element replaces similar element. So it's non-metal, if carry negative charge, replaces negative charge. So here Y replaces B in the compound. So instead of A, B, the products are A, Y plus B. So again, in single displacement reactions, one element replaces similar element in a compound. If metal, it will replace metal in the compound. If non-metal, it will replace non-metal in the compound. And the general formula for the reactions is element plus compound produce element plus compound. Here element plus compound, compound plus element, or element plus compound, compound plus element. So this is the general formula for single displacement reaction. So an example, here magnesium plus hydrochloric acid produce. Magnesium is a metal which carry positive charge, and here according to oxidation number lesson, so hydrogen carry positive charge and chlorine is in group 7 carry negative charge. So here magnesium will replace hydrogen in the compound. So the products are, instead of HCl, Mg, Cl2 and hydrogen gas. So it's a single displacement reactions. Metal replaces hydrogen in a compound. Positive replaces positive. Another example for non-metal, for example, bromine gas plus potassium iodide. So here bromine is in group 7, it's carry negative charge, and here potassium in group 1, and so positive 1, and iodine is in group 7, so negative 1. So here bromine negative replaces negative charge. So instead of potassium iodide, potassium bromide plus iodine gas. And if you remember, iodine exists as diatomic molecule, so I2. And any chemical equation must be balanced. So here you have 2 bromine, 1 bromine, so multiply by 2 potassium, here 2. So this reaction is a type of single displacement reaction. Now, the fourth type of chemical reactions is double displacement reaction. So again, displacement mean replacement. And in this reactions, two ions of 2 compounds exchange in an aqueous solutions to form 2 new compounds. So here from the definition, ions of 2 compounds, so reactants are two compounds here to form two new compounds. Then the products also are two compounds. What is the difference between single displacement reaction and double displacement reactions? Here in single displacement reaction, the reactant element plus compound, the product element and compound. Here, the reactants and the products are two compounds. So, in this reaction, ions of two compounds exchange. So, for example, if you have A, B plus X, Y, for example, what are the products? So here, positive, A carry positive charge and B negative, and here positive and negative. So A will replace X and X replace A, or B replaces Y and Y replaces B. So for example here, A replaces X and X replaces A. So the rule is fixed. One element replaces similar element. So if positive replaces positive, if negative replaces negative. So what are the products? Here, instead of AB, it's XB plus. Instead of XY, it's an AY. So ions of two compounds exchange to form two new compounds. So again, the general formula for double displacement reaction, two compounds in the reactants, two compounds in the product. What happened in this reaction? Ions of two compounds exchange to form a new two compounds. So there are three types of double displacement reactions. So here, types of double displacement reaction. What are the types? A, neutralization reaction. Neutralization reactions. The general formula for neutralization reactions is acid plus base produce salt and water. So here, acid, substance that contains hydrogen ion, and base, substance that contains hydroxide group. So the products are salt and water. Still the general formula, two compounds produce two compounds. So here, two compounds produce two compounds. But if the reactants are acid and base, so it's called neutralization reaction. An example of a neutralization reaction, for example, hydrochloric acid plus sodium hydroxide. What happened in this reaction? The same rule. Here, positive, negative, positive, negative. So, hydrogen replaces sodium and sodium replaces hydrogen. So, the compound or the products are, instead of HCl, NaCl plus, when hydrogen reacts with hydroxide, they form water. So here, acid plus base produced salt and water. Two compounds produced two compounds. It's a double displacement reaction. And which type of double displacement reaction? Because the reactants are acid and base, it's called neutralization reaction. Now, the second type of double displacement reaction is gas formation reaction. From its name, gas is produced from the reaction. So again, it's a type of double displacement reaction. So the reactants must be two compounds and the products two compounds. But if one of the products is gas, so it's called gas formation reaction. An example, for example, hydrochloric acid reacts with sodium carbonate. So here, the same rule, ions exchange to form two new compounds. So here, sodium replaces hydrogen and hydrogen replaces nitrogen. So instead of HCl, NaCl, and hydrogen with carbonated group, it forms carbonic acid. It's direct dissociate to water and carbon dioxide gas. So here, two compounds form two or more compounds, but one of them is gas. So it's a gas formation reactions. The third type of double displacement reaction, precipitation reaction. Precipitation means undissolved substances. So precipitate will formed in the reactions. So here, one of the products is solid. Precipitate is formed in this reaction. So precipitate is formed in this reaction. Again, precipitate means undissolved substance, solid state. So for example, if you have silver nitrate and sodium chloride. Silver is a metal, nitrate, it's a polyatomic ion that carry negative charge, and here sodium positive and chlorine negative. So the same rule, it's a double displacement reactions because the reactants are two compounds. The rule is ions exchange to form two new compounds. So instead of AgNO3, NaNO3, and instead of NaCl, AgCl. AgCl is slightly soluble in water, so it precipitates at the bottom of the beaker. So here, solid. So what is the type of this reaction? The reactants are two compounds. It's a double displacement reaction. And because one of the product is solid, it's called precipitation reaction. So again, in double displacement reaction, the reactants two compounds, two or more compounds, the products two or more compounds. المهم إنه compounds. So ions exchange to form two new compounds. Types of double displacement reactions: neutralization, How to get that the reaction is a neutralization? The reactants must be two compounds, and one of them is acid and the second is base. So it's a neutralization reaction. Now gas formation, how to get that the reaction is gas formation reaction? It must be here two compounds, the reactants two compounds, and one of the product is gas. So it's called gas formation reactions. What about the third type? Precipitation reactions. Here the reactants two compounds, so it's a type of double displacement reaction, but here one of the product is solid, so it's called precipitation reaction. Now type number 5, combustion reactions. In combustion reactions, combustion means combines with oxygen and releasing large amount of energy as heat and light. What is the general formula of combustion reactions? Hydrocarbon compound. Hydrocarbon compounds, from its name, it contains hydrogen and carbon. Here combines with oxygen, so plus oxygen. The products are fixed: carbon dioxide gas and water. So in combustion reactions, the general formula hydrocarbon compounds plus oxygen, and the products are CO2 and H2O, fixed. So here an example: methane gas. It's a hydrocarbon compound plus oxygen. You can complete the reaction, the products fixed. So here CO2 plus H2O. All substances are gases, and you have to balance the equation. So here you have one carbon, for hydrogen here 2, so you have to multiply by 2. So number of oxygen 2, and here 2, 4, so here multiply by 2. So now it's a balanced equation. Okay. Hydrocarbon plus oxygen, the products are carbon dioxide and water. It's a combustion reaction. So again, the general formula for combustion reaction: hydrocarbon compound plus oxygen gas, and the products are carbon dioxide and water. Note in the question, if the reaction is incomplete combustion. Incomplete combustion means no enough oxygen. So here the product CO2 and water. So instead of CO2, the products are carbon monoxide and water. So instead of carbon dioxide, carbon monoxide. So again, combustion means reacting with oxygens and release large amount of energy. General formula: hydrocarbon compounds plus oxygen, the products are fixed: carbon dioxide plus water. But if in the question the combustion is incomplete combustion, you have to know that the products are carbon monoxide and water. So now the last type of chemical reactions: oxidation reduction reactions. Or here reduction and here oxidation, so it's called the redox reaction. So what about oxidation? What about reduction? Oxidation means losing of electrons. So when an atom loses electrons, charge increases. So here charge increases. What about reduction? The reverse. Reduction means gaining electrons. So when an atom gains electrons, charge decreases. So an oxidation reduction reaction involves a transfer of electrons. So in any chemical equation, if you have substances or element, the charge increases between reactant and product, and another element, the charge of it decreases from reactant to product, it means oxidation reduction reaction. Example. Magnesium plus oxygen to form magnesium oxide. Here you have to balance. So this is the equation. It's a type of oxidation. It's a synthesis reaction because one product produced. And it's a type of oxidation reduction reaction. Why? Here, what is the charge? You have to get the charge for each element in the reactants and the product. So here magnesium, one type of atom, so the charge is 0. Oxygen, one type of atom, the charge is 0. You have to remember chapter 7, section 2, oxidation number lesson. So here magnesium, it's in group 2 in the periodic table, so positive 2, and oxygen is in group 6 in the periodic table, negative 2. So what happened to the oxidation number for magnesium? The charge in reactant 0 and in products positive 2. So from 0 to positive 2 increases or decreases. So here charge increases. It's a definition of oxidation. So here oxidation. Now what about oxygen? The charge changes from 0 to negative 2. So here charge decreases. Decreases means reduction. So in this reaction, element oxides and element reduced. So it's an oxidation reduction reaction. What about another example here? For example, potassium plus hydrochloric acid produced. It's element plus compound. If you remember, it's a type of single displacement reaction. So here potassium positive charge, it will replace hydrogen. So potassium chloride and hydrogen gas. So you have to balance the equation. Here you have 2 hydrogen atoms. So here 2 chlorine, 2 and 2 potassium 2. So now it's a balanced equation. It's a type of oxidation reduction equation or not? You have to check the oxidation number for each element. So here potassium, it's one type of atom, so 0. Here HCl, hydrogen carry positive charge and the chlorine negative charge. Here KCl, potassium, it's in group 1, positive charge, 7, chlorine is in group 7, so negative charge. Here one type of atom, 0. So what happened to potassium? The charge changed from 0 to +1. So charge increases. So it's an oxidation process. What about hydrogen? Hydrogen from +1 to 0. So charge decreases. It's a reduction process. What about chloride? Here -1, -1. Oxidation number does not change. So here you have oxidation process and reduction process. So it's an oxidation reduction reaction. So here you have general question for all types of reactions. But before this question, you have to know if you have substance solid and decomposed to ions, this means not decomposition reactions, because the rule of decomposition reaction, one reactant decomposed to simpler substances, neutral, not ions. So this process is called dissolving in water. Now here you have question. Which of these represent neutralization reaction? You have to remember neutralization reactions means what? Neutralization, it's a type of double displacement reaction here. It's a type of double displacement. Double displacement means the reactants are two compounds. So in a neutralization, one of the reactants is acid and the second is base, and the product salt and water. So you have to find which of these reactants are acid and base. So here it's an acid, but here element, here two salts, and here you have hydroxide, which means base, and here you have hydrogen, which means acid. So base plus acid produce salt and water. This is the definition for a neutralization reaction. So here the correct answer is C. Now what about precipitation reaction? Precipitation reaction, if you remember, precipitation, it's a type of double displacement. So the reactants are two compounds and one of the products is solid. So you have to find two compounds and one of the products is solid. So here element plus compound, no. Here you have two compounds and one of the product is solid. So it's a precipitation reaction. So here the correct answer is B. Now a single displacement reaction, you have to remember single displacement reactions means element plus compound. So here you have to find the reactants element plus compound. So here element plus compound, and here metal replaces hydrogen. So instead of HCl, Z and Cl2 and hydrogen. So it's a type of single displacement reaction. So here A. Now a synthesis reaction, you have to remember synthesis reactions means one product. So you have to find which of these one product. Here you have two products, and here one product. So it's a type of synthesis reaction. So here D. Now what about here? Here you have solid state and ions. It's not a decomposition. For decomposition reaction, if you remember, it's one reactant. But here, this one reactant decomposed to ions. So it's called dissociate to ions. So you have to remember, if you have solid and dissociate to ions, it means dissolving in water. So which of these salt dissolving in water? You have to find solid, the reactant is solid and the product's ions. So here the reactant is solid and the products are ions. So here A. Thank you.